this is the problem, reach end of an array with a maximum score. Now what is the operation that you can do? You can jump from any index I to j that should be greater than your current index, and it is calculated as j minus I into nums of I, right? So I hope you read the question. I think a lot of people solved this question, but they didn't actually have the proof like why it is being done like this. Even initially I solved this problem without any actual proof, then I came to know, like, see here, let us understand this through a sample case, right? So which is 1315, right? So here the sample case is 1315, and initially you'll be starting with this zero index, right? With this zero index. Now what is the operation that you can do? That is j minus I into nums of I, right? Right. So here if you carefully check, see here, if I can jump from 0 to 3 directly, ultimately we need to reach this last index, right? Ultimately we need to reach this last index. So let us say I jump directly to the last index by using 1. That means nums of I is 1, and the absolute difference to my last index is 3 minus 0, right? 3 minus 0. So can I say, so you are getting 3. That means you are using this 1 and you are reaching until the last index. That means can I say you are adding 1 3 times to reach the last index, right? You're adding 1 to reach the last index 3 times, right? But if you can see the next index, which is 3, right? Which is 3. So can I say, see, here you need to achieve the maximum possible score, right? You need to achieve the maximum possible score. That means what it is indicating? It is indicating that you need to use the maximum number. See here, ultimately, if I'm using 1 and if I'm jumping to the last index, what I'm doing? See here, that multiplication factor, you need to see it as an addition factor, right? So ultimately, what is multiplication? It is nothing but addition sum n times, right? Addition of n times is equal to multiplication. So instead of adding 1 3 times, so can I use any number which is greater than 1, so that I can achieve a maximum possible score, right? So can I say, if I use this 3, if I can use this 3, so I use 1 only until I can reach 3, right? So then after that I'll be using 3 to reach my last index. So can I say if I use this 3, so instead of these ones I'll be using this 3 to gain my possible maximum possible score, right? So that will give you 7. So that will give you 7, and there is no greater number than 3, right? So that you can achieve this maximum score. See here, I'll give you one another example, which you can take it as 1 4 2 5 3, and if you can take here, you need to reach this last index, right? If you need to reach this last index from the starting index, right? So if I'm jumping from this index to this index directly, what is that signifying? We are adding nothing but 1 4 times, right? We are adding 1 4 times, because 1 into 0 minus 4, right? So we are adding 1 4 times to reach the last index. So instead of that, can I say, I'll go to 3, I'll jump to only 4. That means I use just only one index, that is 0 minus 1 into 1, right? So that will use only 1. So can I say, I'll be trying to jump to the last index using this 4. So can I say, I'll be replacing all these ones with 4s, right? All these ones with 4s, because I jumped here and then I jumped directly here. Then what will be our score? This is 1 into 1, and this will be 4 into thrice, right? So that you will be it. So you can think like that, and even there is one more greater index than 4, right? There is one more greater index than 4, so which is 5, right? So I'll just use 4 only to reach this 5, because 5 can contribute me more, right? So I'll be using these 2 4s to reach my next greater integer, which is 5, and then I'll be using 5 instead of 4, right? I'll be using 5 instead of 4. Then you can get the maximum possible score as 14 for this answer. So you're understanding, right? So what actually you're doing here, you're adding an integer some n minus 1 times, right? So if you carefully observe, you're adding an integer n minus 1 times. So and you need to check what maximum integer that you can add maximum times to reach your maximum possible score, right? So ultimately, if you can see the multiplication as an addition, because multiplication is a fundamental principle of addition, right? So it builds on the principle of addition. So if you can think like that, then you'll be understanding why actually you need to do like this to achieve the maximum possible score, right? So I'll just quickly show you how I coded this. So initially I assume this element as my maximum element, and this is the position that I have marked, right? So I'll be starting from the 1th index, and if I'm getting any element which is greater than my current element, then I'll compute like how much I need to add to reach that current position, right? So then I'll be adding that to my answer, which is I minus position into current, and then I'll be updating my current with this maximum element, right? and then I'll be marking the position. And yeah, if your position is not equal to n minus 1, then you can directly like what is the case, for which case you can ask me, because see here, if you can try run on this case, see here, after 4 you are not having any index greater than 4, right? Then you will be reaching n. This condition won't be meeting in any ith index in that test case. So in such cases, you need to handle that separately after terminating the loop. So if I can submit this, it is accepted. So if there are still any doubts, just ping me below. I'll be happy to reply you.